today we're going to look at specific proofs, okay, for segments. And like we did some on Friday, which was kind of weird because we hadn't really talked about some of the things you need to know for segments, so a little weird. So again, we're going to take a look at writing proofs involving segment addition and segment congruence. Those are kind of the two we're going to focus on. So in order to do that, we need to know a couple things. Right, so the ruler postulate is not a postulate you're ever going to use in a proof. Okay? Hooray. It's basically telling you that every segment could be measured. Meaning, for every segment, there is a number that goes with it. That's the importance of it. Does that make sense? And the idea is, okay, so if there's a number associated with it, then I could do addition, subtraction, multiplication, division, and those properties that I learned about before still apply. Okay? As long as we're talking about equality. So this is kind of the idea, is like this segment right here would be 3, in this case inches, and then all of a sudden I have a number that's associated with it. So I can do math. Okay? This one is going to be used all the time. Okay? In fact, when we're doing segments, this is the one, the most used one. So what I want to point out to you is this would be the kind of the thing you would want to write in your proof. And the reason for that would be postulate 2-9 or the segment addition postulate. Okay. Like small idea, big idea. Okay. Small idea. Every single segment, big one, okay, big segment, that has like some dot in the middle, like here's AC is made up of 2 pieces. Basically what you're recognizing is this big one is made up of this guy plus this guy. Does that make sense? That's all we're saying. And the reason we would want to do that is this. Let's say in a proof, in the given information, they're talking about AC. But down at the bottom in the proof statement, they want me talking about BC. This is a way to pull that in, right? To talk about BC, all I have to do is recognize that it's connected to this bigger one, AC. Okay? So again, we are always trying to think when we're doing these proofs is like, what do I know? This is what I'm given. These are postulates or theorems. Where do I want to go? Where do I want to end up with? And like trying to connect those two is always the idea. So how do we pull in stuff to connect what we know to the end where we want to go? That's kind of what we're looking at. Okay? So here's a proof. It's a long one. Okay. All right. And we're going to say, like in our heads right now, we're acknowledging that every proof starts off with the giving. Okay? So every single time. Notice it says this at top, and I just want us to be aware of this also. Quick side note. If it says prove that if this, then this, the if part, where is that written? Down below. That's the given. The then part is your proof. Okay? Alright. So, we've got this picture here, and this one's a little long, but I'm going to start off with this AB is congruent to CD. That is my given information. Okay? Hooray, I'm giving you points for just doing that, right? Every time. So do we ever leave a proof blank? No. It's at minimum. That's what we want to put. Okay, now, like what I want to recognize is they want me to talk about AC and BD, right? So they're giving me these little pieces. They're saying those are equal. And what I want to end up talking about is this piece here and this piece here. So here's what I want to do. Let's like rewind really quick. Okay. Before we actually do the proof, I just want you guys to talk to me for a minute. Okay. What are the 2 blue pieces? These are just things like, I'm just saying, what are the 2 blue pieces? This is what I want to end up with. These are the blue pieces. What do they have in common? What do they share? Yeah.
The middle part.
They both have this segment BC in there, right? And so like logically, if we're just thinking kind of common sense, if this piece is equal to this piece, and then I add the same thing, this middle piece, to both of them, what do I end up with? Yeah, those two pieces are equal. Right? You just did the whole proof right there. Like, I just want you guys to see, you understand the big picture if you're able to walk through those steps. Now, the doing, the actual like, okay, well, how do I get there? That's like now we're going to have to pull in all these things. Okay? So a couple ways to do this. Number one, I'm going to say, because we just learned about it, right? We just talked about it. I'm going to say that AC is equal to, or actually, you know what? Let's do this first. I'm going to switch to equality first, because the segment addition postulate has an equal sign in it, right? So first thing I'm going to do is I'm going to say AB is, try that again. AB is equal to CD. We learned this on Friday. How am I allowed to say those are equal? Definition of congruence. Okay. Right, then I'm going to use the one we were just talking about. That again, I want to talk about this guy here, AC. I know that AC is equal to what? Please don't say BD, because we don't know that yet.
AB plus BC.
Okay, it is equal to AB plus BC. That's what the segment addition postulate says. That this big thing here, this big blue one, is made up of two parts, AB and BC. So if you take the two small parts and you add them together, you get the big part. Okay? And similarly, I'm going to put my reason in a second. Similarly, BD is equal to
BC plus CD.
Plus CD. Okay? And the reason for both of those, you don't have to write this as two steps. You could put it as one technically. The reason for both of them is the segment addition postulate. Or if you want to write postulate 2.9, you can. Now, don't forget here, I'm going to write it off to the side here because I'm going to start scrolling. But AC is congruent to BD. Okay. Okay. So now, I want to be really careful. I can't just like magically say that this is equal to this. Because I don't know that AB plus BC is equal to BC plus CD. I don't know that yet. So what I'm gonna do first, okay, is this. You have to catch the reason. I'm gonna say AB plus BC is equal to BC plus CD. Everybody with me? Here's the connection. Does everybody see? I basically rewrote this step right here. But what changed? What did I do on both sides? I added something on both sides. And is it okay in math for me to add the same thing to both sides of the equation? Why? What property of math allows me to do that? What kind of math are we doing? You are doing
addition property.
This is the addition property. Notice the difference. Segment addition is really specific. Two small segments equal a big segment. This is, I'm taking two things that are equal from step number 2, and I'm adding the same thing to both sides. Okay? Now what I'm going to do is this. How did I do that?
If you didn't say
It didn't repeat number 2. The letters are different. Yeah?
You got rid of the middle.
I didn't get rid of the middle.
Oh, it's the middle bits on each side.
Right, I got rid of the B's, but like I didn't actually do that. That's not what I actually did to get from this step to this step.
For number 3 and 4, because they both equal.
Okay.
Because in number 5, you said that they equal.
Do you guys see that this thing right here is equal to this? I mean, this one is equal to this, right? So when I take one thing and I put something else in its place, Brennan actually said this earlier, that is called the substitution property. Okay. I want to be careful, right? And I want to make sure that we see this, right? I understand if we're saying just the letters changed, but the idea is what math happened, what property happened. So I didn't just like drop the letters because that's not the math that went on here, right? I didn't ignore the B's. Sorry about that. They're still part of the problem, okay? And then now what do I have to do?
And you have to change them to the definition of congruence.
All right. Now, there was like an 8th step, and I want us to be aware of this. A lot of times, for sake of neatness for your part, I'm going to put a box up there with like a chart with lines. I'm never implying, unless I specifically tell you, you have to fill all those boxes. Okay? Does that make sense? Okay. I want to make sure we understand. Sometimes you might do a proof that's a valid way to do it and a shorter way than I do it. And that's okay. Alright? We just want to make sure that we're really careful. When we're done, no matter how many boxes we fill up at the end, we're going to write something like this or whatever you'd like, right? Happy face. Crouching tiger. Hidden dragon. Never seen that. Alright, you can draw whatever you like. Panda bear. Flowers. TNT. Alright, we good? Okay. Now again, please understand this, you guys. This is not like, man, you have to have this perfect right now. Right. What I would say is, hey, tonight on your homework, maybe you want to look back to this one. And if there's one that's very similar, you're kind of thinking like, oh, what did we do on this? What were things that might help me? Oh, we switched to equality. Ooh, this is how we used the segment addition postulate to help us. Okay, yeah.
Wait, what's the difference between the transitive property and
substitution?
Yeah, because like they're usually used in like the same way.
So the difference is this. Substitution works for equality, not for congruence. Substitution, you could plug into an equation, right? So, for example, if I had, x plus y equals 10, and I said x equals 5, substitution says I could do 5 plus y equals 10. That's not the transitive property. Transitive property is when you're replacing basically one entire side of an equation for another. So it's a, if I can say it this way, this transitive property is a subset of substitution. It's a smaller portion. It doesn't apply as much. So you could have used it here, but for our point of purposes, we haven't even talked about that yet, and we're going to get that today. A little bit. All right. Oh, okay. There's the answers. There you go. Okay. These are more of the ones I'm going to start you off with, especially like your first. I think on your first test, what I'm going to do is give you one like fill in, and one that you have to do by yourself. And we're trying to see like how we do. And the idea is we're growing in these as the year goes on. So I didn't even give it to you. I didn't give you anything, but it says, hey, well, like filling in. So you're seeing this. Notice they did use the transitive property here. AC is equal to AB. AB is equal to BX. Notice these are the same. So they dropped that, right? So they're replacing this entire thing. If you put substitution here, that would be fine. Because it does work. Brendan, to answer your question, where I would say be careful. If you're in congruence, you should never use substitution transit property. Okay? If you want to switch to equality, you can basically use either one. Alright? Notice also what they did, and this is really weird for students sometimes. They didn't use all of the given information. So let's say this is blank. A lot of times students are looking at this step trying desperately to figure out some reason. They're like, this postulate, what postulate is it? It's 2.7. And like the idea is it's actually in the given information. You just have to open your eyes and pay attention. Right? Like they're giving you a free step on the proof. Now here's easy points, but you have to recognize that this was written in the given. Okay, so be careful about that. Then they did addition. Notice what they did here is because these are equal, they're adding the same thing to both sides. And then they're saying, okay, now what happened? So what is this? Yeah. This would be segment addition question. Notice what they're saying. AC plus CY equals AY. And you can kind of see that they go from the first to the last letter at the end, right? BX plus XD equals BD. Okay. And then substitution. Okay, very similar to the previous one. And this is like, in my mind, this is what makes proofs easy. Right? Not that they're always this way, but a lot of them are going to be really similar. So if you're paying attention to the ones we do in class, when you get to your homework, it's like, oh, well, we did two like this. How can I use these and do something similar on this one I'm being asked to do on my own? Yeah?
Where did they get this stuff for number 3 from?
So yeah, I kind of clipped this out of context, right? So in this problem, they gave you given information, and then these two pieces were separate. Right. So again, I wouldn't, in this context, I wouldn't leave this blank. But if I gave you given, proved, then I would expect you to catch that this is part of the given. So again, I'm just trying to draw our attention to the fact that they are going to split the given information from time to time. All right, some of the other properties, okay? And these are congruence. So I said earlier, so transitive property works for congruence. You don't have to switch to equality. If you recognize there's a connection there. Same thing with reflexive and symmetric, okay? Reflexive property, everything is congruent to itself. This marker is the same size as this marker. Okay, now I know, you might be thinking, why would I ever want to say that? Okay, so we're going to fast forward really quick. If I'm trying to say that this triangle is the same, congruent to this triangle, do you guys see how they both triangles share this side? That's where the reflexive property would come in. Right? And the idea is that piece, AB, counts once for the right triangle and once for the left triangle. I know I said that backwards for you guys, so I apologize. Okay, that's right. So the idea is this would be, referring to this side, and this would be referring to this side, but they're the same thing, but you have to recognize that one piece is shared by both triangles. That's where the reflexive property comes. Okay, symmetric property, basically AB is congruent to CD, CD is congruent to AB. If you remember back from algebra, pre-algebra, symmetric property sounds a lot like the commutative property. Remember commutative, you could switch the order of addition and subtraction, or addition and multiplication. Okay, and then transitive is the long one. So notice, how many things are we talking about here?
1.
Technically 1. I know there's 2 of them, but you're talking about 1 piece here, you're talking about 2 pieces here, you're talking about 3 pieces here. Right? Does everybody see that okay? Alphabetic order. R, S, T. 1, 2, 3. Okay? Because this is what happens. You're going to have a problem on the test, and it's going to say, name that property. And it's going to give you a situation like this, and a lot of people end up putting in reflexive property. So I remember they're in alphabetical order. Reflexive, symmetric, transitive, 1, 2, 3. Reflexive is talking about one thing only. Blank is equal to itself. Symmetric property, if A is congruent to B, in this case AB is congruent congruent to CD, then CD is congruent to AB. You could switch the order. Okay? And transitive, kind of like the law of syllogism, like Maddie was talking about. There's 3 concepts. All right, so here's the proof. Again, we're going to fill in a little bit. And I'm going to try to put this whole thing up so you can kind of see the picture. So notice they gave us a bunch of stuff. They said GD is congruent to BC. Okay. And BC is congruent to FH. And FH is congruent to AE. Okay, now I just mark them all this way. What does one mark mean? If I do this and this, what does that mean?
They're congruent.
Those are congruent. And this guy, since it's already marked, is congruent to FH. Those are congruent. So I'm not going to put new marks on there. So what does that mean about all of these pieces?
They're all congruent.
They're all congruent.
Equal.
They're all congruent.
Oh yeah, congruent.
Notice they're all congruent here all the way through. I could switch to equality, but I don't need to. Okay? Do you have a question? Alright, so all of a sudden what they did, they started with this given information. They said, now all of a sudden GD is congruent to FH. How do I know that? Yeah.
Oh, transitive.
This is the transitive property. Okay. It's the transitive property. Notice these are the same, and if I ignored them, I have the first and the last. That's what the next step says. All right. Then they told me this FH is congruent to AE. How do I know that? Yeah. Yeah. Notice again, they did split up the given information. Or you could say this, and I'll do this a lot while we're doing proofs. If I've talked about this and I've talked about this, I'm acknowledging there's still part of the given I haven't talked about yet. Okay. Hint. They're never going to put something in the given that you shouldn't use in the proof. So if you don't use it, it means you did something wrong. Okay? So it's kind of nice to track through. Ooh, have I talked about all this given information? Now, a lot of times, just to save myself steps, I'll put it all in the given information. Like, I'll put it all there, but I'll cross it off as I go. Oh, I talked about, like, now that I've written it here, I talked about this, I talked about this. I'm still keeping track. Okay? All of a sudden, they're saying transitive property again. So what am I going to write here? Yeah.
BC is congruent to AE.
I wouldn't go with that one. It's not what I would go with. Not that you're wrong.
AE equals GD.
All right, I'm gonna write it this way. This is fine. GD is congruent to AE. Notice again, not that you were wrong, Bradley, but I want to connect what's right before it. Notice these 2 steps to this one. What I'm acknowledging is GD is congruent to FH, and FH is congruent to AE. So we're going to get rid of those, and we have GD is congruent to AE. You can see how the flow of thought is. If I have this information, what does that tell me? Okay, and we always want it to be a direct connection, like either to the step right before that or 2 steps before that, unless I'm using something from the picture and pulling that in. And we're just going one by one by one by one by one. Okay? All right. Notice, the way this is written is not what I want. I don't want this. I want it written this way. This is like logistical, and I get it. I'm like, are those basically the same thing? Yes, but that's not true of all things. Okay? Right? Unless you have a very unique name. You know, like Mom. Alright? If we take Brendan's name and we wrote it backwards, it's not the same thing. Right?
Oh yeah,
Not your name. I mean, we have one student at our school right now, in the middle school. In the 8th grade. Evie. You can write her name backwards. And it's still Evie.
Oh!
Okay?
Dude,
But like,
that's so cool.
but that doesn't work for most words.
That's so cool.
Right? Is that fair to understand? So I want to make sure. We have to think through, like, well, does that make sense in math? And yes, it does, and the reason is because of this property, which we're supposed to be putting. Yeah.
This is symmetric.
Symmetric property. Alright. And you guys feel free. Please don't make up your own abbreviations, okay? Don't just write SP, because I'm going to have no idea what you're talking about. That's substitution property, subtraction property, like... So I'm trying to abbreviate for you so you can see you don't have to write everything every time, but let's make sure we kind of write. Questions? Okay. What are we noticing? That's the end, right? Okay, so on purpose, right? I'm not trying to rush through this. You guys have a good amount of time to do these. Okay? And I'm trying to give you time and break things up so we can do it in class and you can ask all those questions and we can work through some of these proofs together. Okay?